So now I want to discuss about performance characteristics of a measurement system. So let's consider performance of a system from the point of input to the output. So this is the input and this is output. Then the curve gives a change of input versus change of the output. So this is very familiar to you from the calculus concept, as this is a slope of this performance characteristics. And so this changes of output with respect to the change of input is a slope, and we call it as a sensitivity. Or if it's a system, then we call this a slope. So this is called the gain of a system. So in general, changes of an input, if output changes are bigger, then this is more desirable, right? So that higher sensitivity is typically better. And if the linear system, which means like twice of the input change will give twice of output, and that linear system, the sensitivity or slope will be constant. In general, our instrument system also has an offset. So for example, the same curve, we can offset this curve. And remember, the offset is just changing the y crossing or x crossing, okay? So which means in terms of the slope or sensitivity will not be affected by offset. So many instruments, in fact, has two knobs, a gain and offset. Offset to make it, let's say, like make it background as a 0, we use offset. And in fact, instruments are physical, and physical instruments are almost always saturated in extremely low and extremely high. So there's always a regimes which is normal operating regime. So you have to check whenever you are using bioinstruments. So this is a diagram showing that. So if there's a too small input, there's a 0 sensitivity. And if you give the input higher and higher, it'll hit into this saturation. So that's a 0 sensitivity. So you want to use it with this linear range, or it's desirable to operate them in the region of highest sensitivity. So this is kind of nonlinear. So we have to generalize for a nonlinear system. How do we define sensitivity at the point of input 0, and that instantaneous derivative or slope of output with respect to input, or local slope where input 0 is the operating point as a sensitivity. So you can see this input and output in general nonlinear system, you can define the sensitivity as the point slope. And you can make this as a lookup table. Okay, so next time we'll study about generalized Ohm's law, and thank you for your attention.